So basically, we are here to know what is Snowflake and what is the importance of Snowflake in today's world, and how are the jobs in the market for the Snowflake, and how do we how do you know crack the jobs in the market in the current IT industry. So what kind of training you need to get crack the job into as a Snowflake engineer or whatever it is. So basically, in traditional days, when I say traditional days, prior to 1990s, 90s, 2000s, we used to have this on-premises system. So Snowflake is something, before I talk about traditional system, Snowflake is something, it's in a cloud database. To in a simple terminology, we call it as a cloud database. Why people term this as a cloud database? Because so we no need to install any servers, no need to have any maintenance. It's a cloud technology where you can use this software and you can pull the data, you can store the data in the Snowflake. They term it as SaaS. They termed it as SaaS. SaaS means software as a service. So they'll provide you the software. You can do whatever you want to do, and all service maintenance will be done by the Snowflake team. So prior to this, when Snowflake was not there, we used to have traditional database system. We call it as on-premises. For example, if you are an entrepreneur or if you have a business running, so you have to store the data in some systems, right? You have to store. For example, if you have a grocery store, what you will do all the billing and all the items which are purchased in your grocery store. Will store it in a database or the warehouse which you allocated for that. So if you want to, from the down the line next 10 months or down the line next 2 years, if you want to analyze the data, and if you want to analyze how your enterprise is doing so far from the last 2 years, so what you will do, you will try to whatever the data is stored in a machine, you will try to do some historical reporting on top of it. And whatever the data is stored, you have to have a physical location for that initially. So you have to have physical location. One system, one or two members has to monitor the systems, and you have to do the job loads and everything. So maintenance is a very big challenging task there. So Snowflake, we came up with a new thing called it a software as a service. No need to have a maintenance. No need to maintain anything. So Snowflake providers will maintain everything, and uh, just what you have to do is you have to use those software, or you have to use those application, whatever you want to do. When I say whatever you want to do, you want to load your data into Snowflake, you want to do is modeling in a Snowflake, whatever you want to do it, you can do in Snowflake. So why people are showing interest to the Snowflake? Because Snowflake handles structured and semi-structured data. Snowflake handles structured and semi-structured data, because nowadays data is growing day by day, right? It is very much, it's a big challenging for the people, or big challenging for the IT industry to store the information. So for that is the reason Snowflake was come up with a solution where it can handle any kind of data, let's say structured data or semi-structured data. So that is the reason. So people are using their data warehouse as Snowflake. This is the next reason. And the third reason is, as I said, there is zero maintenance. So when you are running a business, you should not have any maintenance thing, right? For example, if you buy a car, sir, if you buy a car, you need to take it to the service for maintenance, right? Every 1 or 2 months, you have to get it maintenance. So that is where your car will be in condition and you can do whatever you want to do. So here, but coming to Snowflake, you don't have any maintenance. All the maintenance will done by the Snowflake team itself, snowflake vendor. So this is zero maintenance cost. So what is costing for you is whatever the data you are storing in the Snowflake application, that will be costing for you. This is the only way you have to uh, pay to to the Snowflake team. So software as a service, and this also called pay as you go. So whatever you consume or whatever the data you store in Snowflake, for that data you have to pay to the Snowflake team. And what kind of data you can store in Snowflake? As I told you, you can store structured data and semi-structured data. So when you talk about traditional systems, we used to store the data in data which is in the form of structured format in traditional system. It was not much capable of semi-structured data, but our Snowflake is capable of structured and semi-structured data. We can store the data in Snowflake using any kind of data, semi-structured or structured. For storing the data which is in semi-structured format, we have a different mechanism altogether. How should we load the data into the system and all that stuff. But structured data is it straightforward how we load the data in the traditional systems. This is the high level understanding about Snowflake. Before I move on, if you have any questions, you can ask me before talking about architecture of Snowflake.
You can proceed. I understood.
So why Snowflake is becoming so popular nowadays? Snowflake is becoming popular because of its architecture and computational power. So when you choose a product, what you want best things to be that in that particular application, it should be more reliable. Data should be more reliable and should be very faster to access the data, and it should be very much accessible for the everyone. And the fourth point is data security. So you need all those features whichever you want to opt it, right? First thing, the data should be very much faster retrieval of the data, and reliability, which means when I say reliability, data redundancy should not be happening over there, and it should be easy to use. First thing. And the fourth thing is it should have security governed automatically. Security has to be maintained automatically, right? Our security should be very sophisticated in any of the application or any of the software which you want to opt it. Snowflake will come up with all those, whichever we talked so far. So that is the reason people are trying to use Snowflake as their cloud database. And this database has become more popular than Redshift and other, BigQuery or something. And as I told you, this is a ANSI SQL application where you can write your code in plain SQL language. If you know SQL so far, you can maintain this application and you can easily adapt the Snowflake as your next future, no, future thing for you to enter into IT industry. As coming to the Snowflake architecture, Snowflake architecture is three-tier architecture. You're whatever you're saying it is database storage layer, query processing layer, and cloud service layer. This is the architecture of Snowflake. When coming to traditional system, let's say SQL Server, Teradata, Oracle database, whatever it is, so they don't have this kind of architecture. When I say they don't have, which means they do have all those cloud service layer and data storage layer and query processing layer, but they are tightly coupled each other. They used to have a one mechanism which have data storage layer, query processing layer, and all your metadata information, everything will be tightly coupled. But here in Snowflake they are decoupled each other. Storage layer is separate, compute processing layer is separate, and cloud service layer is separate. They are decoupled each other. They don't have any interconnectivity between them. But the thing is, how they work is, for example, if you want to store the data in your databases, right? So where do you store? At least you have to store that in your any of the servers or whatever it is. But here in the Snowflake, data will be stored in database storage layer. All your data resides in database storage layer. Okay, this is the portion where you store your data, database storage layer. And query processing layer is something, for example, if you select star from employee, that what does it do is The query processing will be done at query processing layer. Whatever the query you run across, that that will be taken care by your query processing layer. And you see we have different virtual machines here, which is nothing but your compute engine, CPUs. So how much processing power you want to add it, you can add it in the virtual warehouses, and that warehouses will try to process your query based upon the compute power you are assigning to it. So that will be taken care by query processing layer. The last one is cloud service layer. Cloud service layer now talks about your authentications. For example, if you're logging into the SQL Server system, you will do SQL authentication and Windows authentication using your user ID and password. So here also same thing, but this will take only the part of user authentication, query optimization, and metadata information. For example, if you create any table, that structure will be maintained in cloud service layer, right? This is the Snowflake architecture. And Snowflake architecture will not suffice by itself. It needs some third-party cloud providers. Snowflake will sit on top of any of your cloud providers. Let's say Azure, AWS, or GCP. This Snowflake will sit on top of any of your three cloud providers, either it is AWS, Azure, or GCP. You need to opt any of the one. Without that, your Snowflake will not work, because Snowflake is a data warehouse, right? So it is a data warehousing tool where it needs the data to be loaded. So for the loading purpose, you need any of these cloud service providers, either Azure, AWS, or GCP. Using these cloud providers, you can load the data into your Snowflake application. So this architecture we can discuss in detail in the regular classes, but as an high level understanding, Snowflake will have three-tier architecture: storage layer, compute layer, and cloud service layer. This is also called database storage layer, query processing layer, and cloud service layer. So every layer has its own importance. Database storage layer will store the data, whatever the data you load into the system. This stores in storage layer. And when you try to process the data, when I say process, when you do select star from employee, if you want to have a look at your data, how the data is stored in your particular table, that will be taken care by your query processing layer. And cloud service layer, it more talks about metadata information. I try to how to optimize your you know um, data or queries, and how do you do authentication and access control, everything, data security, everything will be controlled by your cloud service layer. All those are decoupled each other, they don't have any interconnectivity between these three layers, they work independently. So this is due to this architecture, it is uh, becoming uh, very much in the market. People are trying to use this Snowflake as their next cloud technology, and many of the organizations are looking for to have database as their as a Snowflake as their application, as a cloud provider, right? So long story short, Snowflake architecture is a three-tier architecture, and this is the architecture of your Snowflake. And inside this, how do we load the data and how do you pump the data and everything? We'll talk in loading the data into Snowflake. How do we load the data? Snowflake itself we cannot directly load the data into Snowflake. Snowflake needs a helping hand. When I say helping hand, that needs another cloud providers where the data resides. Consuming those data, it will load the data into our Snowflake engine or Snowflake application. So where these three, we talked about AWS, Azure, and GCP, right? These are the cloud providers to the Snowflake. As I told you, Snowflake will sit on top of any of the application before selecting or before installing or before uh, you know downloading or whatever it is, you have to select on which application you want to store your Snowflake, either on AWS, Azure, or GCP, right? So once you select that, those cloud providers will act as your source of truth. So acting that as source of truth, you will try to pull the data from any of the source system and will process the data in our Snowflake and store it in any of the tables, which are the tables you want to store it. And Snowflake will also load data from the internal systems. Either, for example, if you have data residing in your Windows machine, you want to load that into your Snowflake application. Still, that is possible. We can load the data from your Windows machine, Linux machine, Unix machine, however you want. Those data can also be loaded into the Snowflake. How we load, how many types of loading we have in Snowflake, that we'll talk in detail. Before we move on, do you have any questions in this? Are you able to understand or not?
Yeah, yeah, I'm able to understand. You can proceed.
Yeah. So the loading will be done in Snowflake in two types: bulk loading and continuous loading. When you talk about bulk loading will be done in a single shot. For example, you have one single file you want to load at one particular instance, right? You want to load it as a one time load. So that consider as a bulk load. So you will not be touching the data again, and you want that to be loaded at a single shot. So we will use bulk loading mechanism, and we will load the data into the Snowflake by using copy command. Okay. And how we load the data, because data resides somewhere in Azure or AWS GCP, that is, we'll talk in detail in regular classes. So we'll create a stage, and before creating a stage, we'll create a storage integration between two systems. When I say two systems, Azure versus Snowflake, or AWS versus Snowflake, or GCP versus Snowflake, we'll create an integration between these two systems. Once the integration is created, then we'll create a stage in the Snowflake. Using this stage, we will try to load the data into Snowflake. Loading the data, as I talked now, it is two types: bulk loading and continuous loading. Bulk loading is a one time load. Continuous loading is smaller chunks of data we have to load continuously, day by day, or weekly, or monthly, whatever it is. So bulk loading, using copy command, we will load it. But when coming to continuous loading, for every day you want to load the data, every day there will be file reside somewhere in your Azure systems. You want to load this continuously every day, right? So this sequential loading requires the Snowpipe as a continuous load. Snowpipe is a feature in Snowflake which will allow you to load the data into Snowflake without human intervention. We will set up a pipeline. We'll set up a pipeline using Snowpipe. This Snowpipe will try to load the data into your destination tables without human intervention. So that mechanism will consider it as continuous loading. So Snowpipe is the future. It will load the data into your Snowflake as part of continuous loading. And before that loading Snowpipe, we have different features in Snowflake. Along with Snowpipe, we have to use other features of Snowflake, which will allow you to sit, or which will allow you to push the data into your Snowflake tables. You cannot load now and then, right? For example, you have received a file now, you want to process it tomorrow 8 a.m. EST. So during that time only, 8 a.m. EST, you have to run the pipeline, or you have to run your Snow pipe. So how do you do that? In order to achieve that, we have different features in Snowflake. Using that features, we will load the data into the destination tables. So we have features like time travel, cloning, sharing, streams, catching, task, and many other things. Using task, we will try to schedule the job to run at a particular point of time. Let's say if you want to run the job at 8 a.m. EST, what does it do is 8 a.m. EST, this task will trigger, and it will go back and touch the Snowpipe. Snowpipe will try to identify if there are any files or resides in your external system. If there are any files resides in an external system, it will try to process the file at a given point of time. What are the scheduled time you selected, right? Using that mechanism, we will try to load the data into your Snowflake tables. And coming to, um, for example, as I said, if the data is in your Windows machine or Linux machine, how do you process those files? You don't want to store your files on cloud providers. Those are very sophisticated and it is highly secured files. You don't want to store them. Assume that. How do you process them? We can process them using put command. I don't know whether this is visible for you. We can process those files using put command. Here you see copy and put command, right? So we can process those kind of files also. If the files resides in your local file system, still we can process those files using command called put. This put command, what does it do is it will try to extract the files from your on premises. When it's on premises, from the local system, those files will be processed and will be loaded into the Snowflake, again using copy command. I'm sorry. So here you see there's a put command which will try to put the files into the internal stages. We have different types of stages in Snowflake, internal and external stages. They will try to put the files in internal stages. In internal stages, using these internal stages, we'll create a copy command. Using this copy command, we'll load the data into the Snowflake tables. And in internal stages, we have different types again: user stage, table stage, and named stage. So whichever is suitable for the data to load it, we'll use those internal stages and we will load the data into the Snowflake. Using this is internal stages, which we talked just now, which is about Azure systems or AWS or GCP. Those considered as external stages because you are getting the data from external cloud providers. Those are considered as external systems, and these are considered as internal systems or internal stages. So using this, we'll try to load the data into our Snowflake. And if it's a continuous loading, we'll use Snowpipe is the mechanism which will try to load, or it will try to ingest your data into Snowflake tables every day or bi-weekly or monthly or once in a month, that we will categorize accordingly depending upon the requirement. And coming to, sorry, before I move on, any questions in this loading?
No, no, you can proceed.
Yeah. So, okay. So once the data loading is done, and there are many other ways which we can use our Snowflake features. When I say, every Snowflake feature has its own importance. For example, if you want to share your data to the counterparts or downstream, how do you share your data? We will use a feature called sharing mechanism. For example, if something there is a production issue, right? So there is a production issue and you want to debug that production issue. So you cannot directly debug the issue in production system. We need to have some mechanism. That mechanism is called cloning. You can clone your entire production system into your dev system and you can debug your issue. That we consider it as cloning. Cloning is nothing but mirroring. So, right? There is a concept called time travel. For example, somebody has deleted the table in production system, which means we won't give any explicit access of delete role to the any of the users. Assume that somebody has deleted the table in the production system. You want to roll back the table again. So this is the coolest feature in Snowflake. Using time travel feature, we can retrieve the historical information or deleted tables or deleted query, whatever it is, that we can done it using time travel. And continuous data pipeline, that is nothing but your Snowpipe, which is used for loading the data into your Snowflake on day-to-day basis. And streams. Streams talks about more about your um, incremental changes, delta changes. So for example, if a file is loaded today with a record called 100 with a value of X, and from today in the system, it has been changed to Y. Same 100 record has been changed to Y. So that kind of DML changes or delta changes will be controlled using streams, right? And the last one is catching. Catching is something everybody know about catching. So catching is a temporary memory which will try to improve the performance of your queries. Snowflake, we have different kind of catches: query results catching, local disk catching, and remote disk catching. Same like your Snowflake architecture. In Snowflake architecture, we have data storage layer, cloud processing layer, this one, processing layer, and cloud service layer. In the same way, catching also we have three types: remote disk catching, local disk catching, and query results catching. So every layer has its own importance. For example, if you ran select star from employee, right? Select star from employee. Let's take it took 2 minutes for the first time. When you run the same query in the second time, it will not take 2 minutes. It will take less than 2 minutes. But the same query, if you run in on-premises system, let's say SQL or Oracle or whatever it is, it takes the same amount of time in the sequential runs also. But in Snowflake, it is not the case. That is possible only because of catching. So it will try to store the data in the temporary memory. And when you run the same query again and again, it will try to improve your performance of the query. So that mechanism we have in Snowflake, they call it as catching. And partner connect is something you can connect to any of the external systems, like third party applications we have which support Snowflake. They can do integration, they can do BI, whatever you want. They have different partner connects in Snowflake. So these are the features, not all the features. These are the few features which we use on day to day basis in Snowflake. Any questions?
No, no, no. I understood.
Okay. So I also attached here course content which we talk on Snowflake, right? You can go through them.
Mm.
If you have any particular queries, you can ask me. So we will talk more about, initially we'll talk about introduction to Snowflake, why Snowflake coming into existence, what
Mm.
made the changes to Snowflake in nowadays evolving industry, and what are different types of cloud platforms which support Snowflake, and how do we load the data into Snowflake, and what are the file formats which Snowflake can support, and how do we access the data from the different cloud systems, and how do we unload the data. For example, we are loading the data into Snowflake, so we from the downstream they need our data. So for example, employee table, we loaded it from the cloud provider, or let's say Azure systems or GCP systems. We processed it, we transformed it, and we load into Snowflake. Whatever the transformed data, that data, let's say employee information, downstream needs that. Downstream maybe any of the source Salesforce team, or any of the downstream needs this. How do you unload this? They need some file format, they need the download, sorry, they need downstream needs the file in some particular format, let's say CSV format or JSON format or whatever it is. How do you do unload the data from the Snowflake? That we'll talk in the regular sessions. And coming to next is, as talked about futures, we'll talk about Snowpipe at partner connect, and how do you handle different types of files and how do you load them in the Snowflake. Let's say JSON is one of the file format among Snowflake for file formats. How do you handle this JSON formats? How do you handle the CSV formats? How do you handle Parquet file format? How do you handle ORC formats? So we'll talk about JSON, XML, CSV, and Avro files. So we'll come to know how do we load this data into Snowflake. Those are called different file formats. And next is, how do you schedule the pipelines to trigger at particular point of time, right? That is creating task streams, right? So streams will identify the change data captures, and task will try to do schedulings at particular point of time. This has to run on this particular time. We will try to use tasks. We will take the help of task and we'll schedule the jobs accordingly. And sharing. So for example, as I told you, if you want to share your data to other Snowflake users or non-Snowflake users? How do you share them? Those sharing mechanism we'll talk. And cloning. We'll talk about cloning also. And the last one is time travel and file safe. If something is deleted in the system, how do you revoke it back? Right. So we have certain limitations in revoking the data from the Snowflake applications as well. We'll talk about all those enabling, disabling, data retention time, and clustering and performance techniques. We'll talk in detail in regular classes.
Okay.
Anything specific you want to know, or
That's it, I think. Because I'm just seeing the demo now newly. So whatever you told, I understood.
okay, fine, okay then.
Okay.
So if you have no questions, we can wind it.
Yeah, yeah, fine. Thank you. Thank you.
Okay then. Thank you.
Thank you.